Welcome student. Here we have to define the relations between E and V. E means electric field and V means electric potential. You know very well what do you mean by electric field, electric intensity. Okay, just in this lecture, previous lecture, we have defined what do you mean by the electric potential. Electric potential is defined as it is the work done to displace a unit positive charge from infinity to that point in an electric field against the electrostatic force is called as a electric potential. It is denoted by letter V. SI unit of electric potential is volt. Okay, let us see the relations between E and V. Okay, consider this figure. In this figure, what is plus Q? Plus Q is the point charge which is situated at point O, and the Q0 is the unit charge which is situated first at point M. Now, when this unit positive charge is displaced through displacement dx, then work is done. That work done is given by the formula dW is equal to the minus F into dx, where F is the electrostatic force acting on unit positive charge and dx is the displacement. Okay, and negative sign indicate that this force and the displacement are in opposite sign. Okay, and the direction of electric field is along the OM vector. Okay, now what is the value of force? Electrostatic force. Okay, the electrostatic force acting on the unit positive charge Q0 is given by the formula F is equal to the Q0 into E. Okay, therefore put this substitution in equation number 1. Then what is the dW? dW is equal to the minus Q0 into E into dx. Rearrange this equation. dW upon Q0 is equal to the minus E into dx. Then what is the work done per unit charge? Work done per unit charge is the electric potential dV. Therefore, dV is equal to the minus E into dx. Since we can write down this dW means work done per unit charge is equal to the dV. Okay, therefore dV is equal to the minus E into dx. Then what is the value of E? E is equal to the minus dV upon dx. This is the relation between electric field and the electric potential. From this equation we can say that the electric field is at that point is the negative of potential gradient. What is dV upon dx? This term dV upon dx is called as a potential gradient. Okay, therefore this is the important relation. E is equal to the minus dV upon dx. This equation shows the relation between electric field and electric potential. Then there is a small point which is the zero potential. What do you mean by the zero potential? You know that the earth consists of it is the huge resources of a charge. Therefore, by removing or adding the electron to the earth, what is the effect on earth? There will be no effect on the earth potential. बरोबर ना? जर समुद्रातलं आपण एक मग पाणी काढलं काय किंवा त्याच्यामध्ये एक मग पाणी टाकलं काय, त्याच्या लेवलमध्ये काही फरक होणार आहे का? नाही. तसंच की अर्थ सुद्धा काय, इट इज द ह्यूज रिसोर्सेस ऑफ ए चार्ज. Therefore, there will be no effect on the potential of a earth by removing or adding the charge to the earth. Therefore, the potential of the earth is taken as a reference potential and it is always equal to the zero potential. This is the standard way to take the potential. Okay, and once the zero potential is set, every potential is measured with the help of this zero potential. Okay, therefore this is the concept of zero potential. Now, next point, potential energy of system of 2-point charges. What is the potential energy? Potential energy is defined as it is the work done to displace a unit positive charge from infinity to that point in an electric field against the electrostatic force is called as a potential energy. Okay, therefore, here we have to find out the potential energy of a system of 2-point charges. Therefore, we consider a system which consists of two charges, Q1 at point A and Q2 at point B, at a distance of R1 and R2 from the origin O. Okay, the distance between Q1 and Q2 is R12. Okay, now initially both the charges Q1 and Q2 are at an infinity distance. Okay, now bring the first charge Q1 to the point A from infinity distance at a distance of R1. Then what is the work done? There will be no work done because W1 is equal to 0. Why this is so? Because there will be the no electrostatic field. Charge Q2 हा कुठे आहे अजून infinity distance वरच आहे. कोणती electrostatic field नाही. Therefore there will be the no work done. Therefore W1 is equal to 0 and the potential due to this charge Q1 is given by V1 is equal to the 1 upon 4 pi epsilon 0 Q1 upon R1. Okay, now to bring the second charge Q2 which is at an infinity distance to at point B at a distance of R2, then what is the work done? Work done W2 is equal to the potential at point B due to the charge Q1 into the Q2. Therefore, we can write down W2 is equal to the potential at point B due to charge Q1 into Q2. Okay, therefore W2 is equal to the potential at point B due to the charge Q1 is 1 upon 4 pi epsilon 0 as Q1 upon R12 into Q2. Okay, therefore W2 is equal to the 1 upon 4 pi epsilon 0 Q1 Q2 upon R12. This is the work done to bring the charge Q2 from infinity to the point B. Okay. Now, as the work done is stored in the form of a energy, therefore potential energy is equal to the 1 upon 4 pi epsilon 0 Q1 Q2 upon R12. This is the equation of potential energy of a system of 2-point charges. Okay, now if the system consists of n-point charges, then this equation becomes, we can write down the W3 potential at point C due to the charge Q1 and Q2 into the Q3. Okay, similarly you can find out the W4 potential at point D due to the charge Q1, Q2, Q3 into the Q4. Okay, therefore W1, W2, W3, W4 अशा व्हॅल्यूज तिथे तुम्ही फाइंड आउट करू शकता. And the potential energy of the system of n point charges becomes, yes, potential energy is equal to the 1 upon 4 pi epsilon 0 summation of Qj Qk upon Rjk from the limits or from all pairs. You can see here you can say the all pairs. Okay, therefore this is the equation of potential energy of a system of n point charges. This is the equation of potential energy of 2 point charges in a system. Okay, let us stop here.